All right, so today you should be focusing on your lab. Lab 3 is due by midnight. But otherwise, once you're done with the lab, you should hit that homework or the homework 1 as much as you can. Again, you should have ideally, you should have a 90% complete, third program right there, so that you're giving yourself enough time that when you do have a bug, you can get yourself the help hours and you can get some help on it. If you take a look at our regular schedule, I believe that the last hours that are held on Friday are like 5 or 6 p.m. You have until midnight, but there won't be any LAs there to provide help. And if a lot of people will be waiting to the last possible second. So it'll be very difficult to get help when the LAs are swamped like that in their help hours. To continue from last time, remember that we were using binary search to try to search these books for Terry Pratchett. Remember that I set the first name to Terry, the last name to Pratchett, and then I created this comparator that compared them by the last name, so that if we had, say, Smith and Smith, Allison Smith and Zoe Smith, they're different, but their last names are the same. So if you have the same last names, then it goes to compare their first names. And so this will return something positive, zero, or something negative, depending on the relative ordering of them. In other words, we can search for books by author. Then we created this dummy key, right? We created a book, and we only set its author's first name and its last name, okay? We didn't set the title because we're interested in any book by Terry Pratchett. If I already knew the title and the ISBN and everything that I was searching for, well, then I'd be done. I wouldn't need to search, right? Or I'd be searching by another criteria. Unfortunately, it didn't work last time, right? We called binary search on books using our key, using our comparator. And I realized 2 seconds after we left why. All right, let's go ahead and take a look at an example here, just using integers. 1, 2, 3, 4, 5, 6. My entire computer is frozen. Hopefully it doesn't. Okay, now we're back. 5, 6, 7, 8, 9, 10. Right? Now suppose that I was just searching for numbers here. It's sorted. So what I'm going to end up doing is looking in the middle, and say that I'm searching for 10. I'm not going to be looking at the left half of this list because I know that it's sorted and it's in order, in increasing order. And so I end up searching in this right half of the list. Once again, binary search goes to the middle of that. 8, 10 is bigger than that, and so it ends up searching this half of that half. The crucial observation here, the crucial property, is that this has to be sorted. So we didn't end up finding this, and let's go ahead and run this again, right? That we didn't end up finding it because we found it at index -75. Why? Well, when's the last time we sorted this? We sorted them by year, right? If this were not sorted, if this were just random values here instead of being sorted, say 10, 5, 7, 3, 7, 5, or 3, 2, 9. There we go. And I'm going to go ahead and look in the middle now. 7. If you're searching for 10, binary search is going to be assuming that it's in ascending order, or that it's in sorted, that it's actually sorted. And so I go off on a wild goose chase here over on the right half, thinking that 10 should be over there, when it's actually over there. And that's what happened here. Because it was sorted by year, and we're trying to search by author, a completely different criteria, that's why we ended up with it being broken. So the solution here is, once we've created our key, before we do our binary search, we need to sort by the same comparator. Collections.sort the books by author. There we go. Collection. I spelled it right. What are you talking about? There we go. All right, so collections.sort. Now we should be finding a book by Terry Pratchett. And in fact, that is by Terry Pratchett, even though we're not printing out the author there. Okay? We can go back to the book and add the author. There's the rating. I'll go ahead and add by, and then add the author, this.author last name, plus comma, because we're going to go last name, first name, by, and then plus this.author first name. There we go. Get author first name. And I've got getters for those, so those are actual functions. And then I will finally concatenate a space just to make it look nice. And let's go ahead and print that out again. There we go. Found a book. Only You Can Save Mankind by, indeed, Terry Pratchett, 1992. I guess I forgot my parentheses there. There we go. Now it looks all pretty. Right, there we go. Right. I found a book. Is that the only book? I think if we print these out by author, you'll find that there are actually 5 books by Terry Pratchett in this collection. What if you want to find them all? Okay? That is my last part of the demo. Here's an even better way. Let's use maps. Before we do that, let's go ahead and make our lives a little bit easier here and go back and rethink what we've done so far. All right? Think about object-oriented programming. Right? We're going to get into that here in the next couple of weeks. But the first thing that you should be thinking about is that course mantra that I started at the beginning of this semester, that smart data structures and dumb code are a lot better than the other way around. One part of that is to start thinking from the bottom up. We started with processing that book data as a CSV file. What we should have done is we should have started over here and defined what a book was, right? Because this is designing your objects, right? And the data that I gave you initially, well, it's an ID, it's a title, it's an author's first name, author's last name, ISBN, rating. Well, let's think about this for a second. That's the data that was given, right? If I were to think about this more generally, right? A book is not just released in a year. Where else? What other data it would be relevant to the published date, right? So it wasn't just released in 2023. It was released on June 28th, 2023. So maybe also a year, month, and day. And I'm choosing to represent those as integers. But now, the point that I'm going to try to make here is that, well, if you've got 3 pieces of data, what should that be screaming out to you? Those of you coming from a C background, 3 pieces of data representing a date, right? More than 1 piece of data, certainly 3. What should you be doing with that piece of data? Encapsulating it in what? In C. A structure, all right? A struct. Those coming from a Python background, did you do classes in Python? No? Okay, then let's go ahead and keep it simple. You've got 3 pieces of data. How can you collect them into one thing? Here's a hint. There's 1 thing, 2 things is a pair, 3 things is a triple, 4 things is a quadruple. What are these things? Emphasizing parentheses here. You could do it in an array, but it's even better in Python would be, tell me you did tuples. No? Here's my Python code. First thing, comma, second thing, right? And then 3, right? You can use this in Python to wrap 3 things up together. That's called a tuple. In this particular case, it's a triple because there are 3 of them, right? So you can go ahead and wrap these 3 things up into a tuple, right? Or you can define a class. All right. Well, if I actually had that data, then I would care about it, right? But actually what I would do is I would not roll my own. I would not create my own date class. Instead, I would probably use local date, right, which is built into the language. Local date, publish date. Right, there we go. And I would have done something like that. Right? Okay. With that thinking in mind, that if you've got 1 or 2 or 3 or 4 pieces of data that logically define a thing, then you should create a tuple for it, or a class, or a structure, depending on what your background is. This is Java, though. If I've got 1 or more pieces of data, like an ID, a title, rating, year, right, representing a book, of course I'm going to create a book class. Do you see any other pieces of data here, though, hint, hint, that may represent something that is not a book? Author's first name and last name. Is an author a book? No. What is an author? A person. So let's make a person class. Right? The whole point of object-oriented programming is that you can make classes to represent real-world objects. Okay? Now, I'm not going to call this author last name, right? Instead, it's a person. A person can be an author, a person could be a student, a person could be a customer, right? So I'm just going to say last name and first name, string first name. This is probably the first thing that we should have done because we're going to be doing this bottom up from now on. We're going to create classes to represent the things that we're working with, Once we've got those classes, then we can start bringing them together to interact with each other to actually do stuff. Right? Now, I'm going to go ahead and design this a little bit differently. I'm going to make these both private. Okay. We'll talk about that later on, but you can make them public, private for your first assignment. It doesn't really matter. But this is good encapsulation because it's strong encapsulation. Nobody can see this first name and last name. Let me show you. Right? So instead of a book as our key, what I'm going to do is I'm going to create an author, which is a person, right, is equal to new author. And if I try to do this, author.first name is equal to Terry, right? There we go. That's not going to work. It can't see the first name anymore. Right? Yeah, go ahead.
Also, should it be a person class?
Oh, it is. Oh, sorry. On the right-hand side, you mean?
Yeah.
Yes. Oops. Person. There we go. Thank you. I was thinking author in my head. All right. So that takes care of that line. But now on this line, we're not able to set the first person, their first name. Why? Because it's a private variable. That's okay. How do we get that Terry and that Pratchett into this class here? Remember that you can go ahead and create a constructor using fields, and it'll write the code for you. Anytime you call person, give it a last name, give it a first name, and it sets those values. We'll talk about this here in a second. Ignore that. I'll get rid of it for now. All right, we'll come back to that much later. All right, let's come back over here. And now instead of setting the first name, I'm going to let the constructor do that for me. Was it first name, last name? Last name, first name. Okay. So Pratchett, right? And then Terry there. And I can go ahead and get rid of these two variables now, cleaning stuff up. Okay. Everything is breaking because we're changing the stuff. We're refactoring it. There. Now I've got my author. All right. Now let's come back over here to the person and explain this a little bit more. What if I didn't have this keyword? All right. There's a warning there. Let's hover over that warning and understand what's going on. The assignment to a variable last name has no effect. Let me show you another piece of code and ask you a question. Int x is equal to 42. X is equal to x. Line 11 there, does that make any sense whatsoever? I mean, it's valid code. It'll run. It'll do what it says it does. But what is it doing? Here's x. You're taking the value and you're just putting it right back in. Same error message or warning message. It has no effect. All you're doing is taking the thing in that variable and putting it into the same variable. So, how do we resolve this? There are two variables called last name. This parameter variable right here and this variable up here. How do I distinguish between them? Because right now, all I'm doing is taking that parameter variable and resetting the parameter variable to itself. That's what the warning is about. Now let's come back over here to the demo. All right, ignore everything that's not compiling. Just pay attention to line 88. What is my variable name? So I created a new person and I stored it in what variable? Author. The name of the variable is author, right? Just like my name is Chris, right? Your name out there is Joe or whatever your name is, right? You have a name to call yourself. But let's go into this person class. Does this person class know anything about author? Or if it's a person like me, does it know that its name is Chris? Does it know that its variable name is Joe? No, I don't see anything like that. Also, if I'm talking about myself, I would not be using my first name. I would not be saying, Chris is teaching a lecture right now, right? That you're talking in the third person. Instead, how would I refer to myself? Myself, right? Me, myself, I. An object is the same. How does the object refer to itself? Well, it's not a person, so, I mean, it's a person class, but the object itself is not a person, and so we refer to it as this. This object's last name, set it equal to the last name that I was given up here. Okay? There, wonderful. We now have a way to create authors. Now I can come up here and refactor stuff. For example, the book class. I don't want to separate the last name and first name anymore. Instead, I want to give it what it has, an author. There. That's much better. Yes, the string is still, the ID is still a string, the title is still a string. There's no way to break that down any further, and you wouldn't want to. The rating is a double, but now the author is an actual person that you can start reasoning about. Okay? That breaks some stuff because we refactored. That's okay. Get rid of that because there's no first name, last name anymore. But at the same time, I want a getter for that author. Let's see, getters, author, right there. There we go, generate. I'm letting it do all the code for me, right? You want the author of this book, go ahead and return the author. I don't have the this keyword here, right? I don't want the setter either, but we'll come back, forget about that for a second. That did actually set this because it needed to, but I don't have the this keyword here because there are not two variables named author anymore. Do you see any parameter variables up here? No. So there's only one author, and that's that variable up there. Okay? So it's still best practice to use this even if you don't need to. And I'll be doing that throughout. Unfortunately, the auto code generation never did that, but it should have. All right, what else is breaking? All right, there we go. Well, now instead of printing out this author's last name, comma, this author's first name, let's just go ahead and print out this.author. There. We're not going to be able to run it, but we'll come back and we'll fix an issue here in a second. Actually, let's fix it now. Do you see a toString method here like we had on book? Right? If you want to print out a book, it's going to call this function called toString, print out the title by author, right? Dot, dot, dot. But now that we're printing an author, do we have the same thing over here? Nope. So let's give it. Right? So public string toString. toString. Because we want to print an author, we'll print it in this order. This dot last name plus a comma, this dot first name. There we go. And now that will have this formatting down here, right? Why did I separate them? Right? I could have done that. I could have printed out the authors first. I could have gotten their first name and I could have gotten their last name, and I could have formatted it here myself. But think about object-oriented programming a little bit here. We'll get into the habit of doing this. You know, stuff belongs where it belongs, right? An ID, a title, and printing that stuff out, that's a book thing. Where does it belong? In the book class. Printing an author, an author is a person. So printing and formatting the name, last name, comma, first name, that sounds like a person thing to me. Where does it belong? In the person class. Right? Oh, return, sorry. There, now it compiles. Right? We'll come back to this later and prove it a little bit more, whatever. Okay? Actually, let's improve it now so that I don't forget. Right? I want the getters, again, just generate them. Right? Now I have a way for you to get the first name and get the last name if you need to compare them for whatever reason. Right? All right, there we go. Good. Come back over here to demo and see what has broken now. The comparator for by author, there's the last name, there's the first name. We no longer have a book getting the author's last name. We no longer have a book getting the author's first name. What do we have instead? We have a getter for the author, which returns a person. Okay? So let's come back over here and change this. Comparing book.getAuthor. Right? There is no first name and last name. Now it's just one thing. Right? It is get author, right? There we go. It's not compiling anymore. Right? So when we looked at searching and sorting originally, right, we had no problems with sorting doubles. Why? Because they were built into the language. We had no problems sorting strings. I did that, right? Here we go. There. A list of names here. Right? All we had to do was give it over to the sorting algorithm and it took care of everything. Why? Because they were built into the language. It knows how to order numbers. It knows how to order strings. But does it know how to order authors? No. Why? Because we wrote that. Does it know how to order people? No. Right? How does it know how to order strings, though? It's not magic, right? The Java didn't just say, okay, well, I know how to do this, right? And became alive in some AI stuff, right? No, somebody wrote it. How did they write it? Let's jump into the string class and find out. So there is this implements keyword that we'll talk about later. Right? And it implements comparable string. In other words, this string is comparable to another string, right? In lexicographic order. Apple comes before banana. Uppercase B, banana, comes before apple because it's lexicographic. Right? How does it do it for integers? Integer x. Right? Let's jump into that class and see what it looks like. This integer is comparable to other integers. Right? Now, how does it end up doing that? There's this compare to method, right? That takes this value and compares it to another value that you give it. Right? I'm going to compare this to that. Right? And how does it work? Well, let's take a look at that. It just hands it off to another function. And what does that function do? Well, if x is less than y, what does it return? Something negative. Otherwise, and this is a ternary syntax, don't worry about it. Otherwise, if x is equal to y, what does it return? 0. Otherwise, what's the only other possibility? 1. They were getting fancy and wanted to write a one-liner instead of an if, else, right? Which I've been doing, and I would recommend that you continue doing. Don't get fancy until you know what fancy looks like, right? All right, so how do we do that here? I want to make this person comparable to that person. I'm going to add implements comparable person. Right? That obligates me to add this compare to method right here. All right? I need to compare this person to that person, ... So what's the natural comparison? I look, like I did before, at the last name, Smith, Smith. If they're the same, then I need to go to the first name. But if the last names are different, if I've got Smith and Burke, my last name, right? Burke comes first in lexicographic order. So these are all strings. I know how to compare strings. This dot first name, or last name, I guess, last name first, dot compare to that dot last name. Right? That is not a great variable name, but I want you to make a distinction between this and that. This function returns something negative, positive, or 0 depending on the relative ordering of this thing. So let's capture that into a result. Int result. It returns an integer. Now, if they have the same last name, what will result be? If it's Smith and Smith, they're equal, so what does it return? 0. If they're not equal, Burke and Smith, it returns something negative. We're done. Don't even bother looking at the first name. If it returns something positive, we're done, right? Don't even bother looking at the first name. Only if the result is 0 should I do something about it. Right? Return this dot first name dot compare to that dot first name. Now what happens if they have the same first name and the same last name? Clearly they're the same person, so 0 and 0. That's perfectly fine. Right? Actually, there's a better way of doing this. Result is equal to, so I only have one return statement, result. Right? So if it's non-zero, then this gets skipped and we immediately return it. Otherwise, if it is 0, then it gets reset and we return it. Nice compact code, but it's still readable. All right? Wonderful. Now over here in the demo, this actually compiles now. Because an author, which is a person, is comparable. I don't know if I have enough real estate for it, but there you go. I can put it side by side. No, I don't have any real estate for it, sorry. That's too small. Sorry, I don't have any real estate. There we go. All right, so now I'm comparing the author. Now I've got my key. Let's call it a key. Right? I'm going to sort my books by author, and I'm going to do my binary search by author. Right? Except that I still need a book here. Sorry, I need a book. Book B is equal to new book, and then B dot author is equal to the key there. And then I can sort by book key, I guess. I do need this as an author. There. All right. Now I'm going to do my binary search in the books using that book key by author, but that book key has its author as Terry Pratchett. Right. And this should still work. What was the book that we found before? What was it? No, I want... There. Only You Can Save Mankind by Terry Pratchett. I should be finding the same... Oops. It doesn't compile. What doesn't compile? over here in book utils. Oh, I still need to fix stuff over here in book utils, right? Instead of last name, first name, what I need to do now is I need to create an author. A is equal to new author using tokens of 2, tokens sub 3. Remember that it's last name, first name, and I can get rid of that. And I can say b.author is equal to A. Author. What is it called? Person, not author. All right. We could probably do a subclass of it. We'll talk about that when we get to object-oriented programming. There. Now that I've fixed that, the demo should work, and I'm still getting that same book, Only You Can Save Mankind by Terry Pratchett. All right? Yeah?
So is the compare to kind of like toString, where because of its name, other classes will know, like won't be able to work?
Anything that assumes that something is comparable will be able to use it. For example, I could have a list of authors. Let's go back to the book. Sorry, person. I could have a list of persons, let's say. And I could order that. I could just call sort now, collections.sort persons, right? And in fact, we'll do that here in a second if we want to print things out in an order, right? That makes it possible right there. Anything that if it's comparable, oh, great. That means that you have this compare to method that I can call to say that this comes before that or vice versa or they're equal.
Okay.
Yes?
So because you implement comparable, it assumes that there's a function called that.
If there is no function called that, then it ain't compiling. Right? You said it was comparable, but you didn't provide me that function. Don't compile. Yep. And so the assumption is correct because otherwise it didn't compile. Right? Right? Good. So now let's go back again to that mantra of the course. One of the themes of the course is smart data structures and dumb code are a lot better than the other way around. I don't want just one Terry Pratchett book. I want them all. But I also don't want to solve this problem just for one particular author. What I want to do is I want to produce a map. The map here will be an author, and they're going to map to, say, a set or a list of the books they've written. Right? Do we want a set or a list? They're all a list? Okay. Then I'll go ahead and do this. A list of the books they've written, and I'm using that square brackets right there. Why? Because not only can I solve this problem for Terry Pratchett, if I'm able to create this map that maps an author to their list of books, imagine what I can do. Right? Just given one person, I can just jump immediately to all their books. I could determine how many books each one has by simply going through all of the authors and saying, well, what's the size of this list? Terry Pratchett has written 5 books in this collection. Right? I can do a whole bunch of powerful stuff if I've got the data in this format. Those coming from a Python background are really going to appreciate this because you can do this in Python with dictionaries. Right? You can map an author, say a string representation, and you can map them to a set or a list of their books. Right? You can do something like that in Python. How do we do it in Java? Well, first of all, I need a map. The map is a key value pairing. What is my key here? It's not a string because an author is not a string. What is an author? A person. Right? Oops, with a capital P. They're going to map to what? One book. I could do it like that. Well, Terry Pratchett has written 5 books in this collection. So how am I going to get that? A list of books. There. So I'll call this author map is equal to new hash map. There. Now, obviously, that doesn't build it. What I need to do now is I need to build it. So step 1, get a list or set of all authors. Right? Then iterate through all of the books. Right? And once I do that, add the book to the map for that particular author. Right? There. I've outlined, right? This is what you should be doing in all of your programs, right? Step 1, I need to open up the file. Step 2, I need to read it line by line. Step 3, for each line, right, indent, now I need to process the CSV part of it, right? Split it out into the tokens, right? Step, right? Then you can come back and fill in this step, right? If you want to, add to-dos. Right? Once you've filled in the step, you get rid of that. I'll leave it here just for illustrative purposes, but don't include that cruft in your code, in your final submission. Right? So let's get a list of all authors. Right? List or set, which one would be better? If Terry Pratchett is going to appear 5 times because he's written 5 books, do I want that, or do I want Terry Pratchett appearing once? 5 or once? Once. So should I get a list or a set? Remember the difference. Duplicates allowed, no duplicates allowed. So the answer is probably a set. A set of persons, all right, authors, is equal to new hash set. Right? Now let's iterate through the books. For book B in the collection, books, right? What I'm going to do is I'm going to add the author. Authors.add b.author. Right? All I'm doing is iterating through the books, and I'm adding it to this set up here. Okay? Let's print it out to make sure that we're getting what we want. System.out.println authors. There. Run it. Right? And I'm going to increase, where is it? There's the tab. Right? So there's Xi Jinliu, there's Chris Grabenstein, there's Yubegni, whatever. Let's look for Pratchett. There we go. Uh-oh. I'm seeing him multiple times in that list. Right? In fact, let me just grab that. Come on. Let me just grab this one line here. And sometimes it's nice to have like a scratch new file. Let's go with scratch.txt. Right? It's just a text file, and you can go ahead and put stuff into it. Sometimes it's nice to have this so that you can take some output and put it over here and manipulate it. So for example, Pratchett. He appears once, twice, thrice, 4, 5 times before I start over. All right, so I didn't get what I wanted. I am getting Terry Pratchett appearing as many times as books that he has. Why? Even though a person is comparable from one person to another person, I still need something else here. Right? How do I know that that person is equal to that person over there? That's a different function. So what I'm going to do is I'm going to come up here to source, and I'm going to generate a hash code and equals method. I'm just going to let it do its thing. Right? So let's take a look at what this looks like. Where's the equals method? There we go. So this is all boilerplate stuff, blah, 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 blah. But take a look at what happens here. Two persons are the same if their first names match and their last names match. Right? When I run this in demo now, I'm only going to get one copy. Right? Let's go back over here to my scratch and get rid of all that. There. Now how many times does Terry Pratchett appear? Donk, 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 once. Right? The idea there is that if you have an equals method, then Java is able to determine, is this Terry Pratchett and this Terry Pratchett, are they the same thing? Because I only want to add them once because this is a set. I don't want duplicates. How do I know that these two things are duplicates? By calling this equals function. Is that one equal to this one? Yes? Okay, then I won't add it. I've still got this one in the set. And again, it is auto-generated code. If you create a class, generally what you want to do is you want a constructor, you want a toString method, you want getters. If you want to make it comparable, then that's fine. But also you should generally have a hash code and an equals method. Don't worry about the details of it. You can always generate it using this in Eclipse. Generate equals and hash code. Right? But if you get weird behavior, like say duplicates in your sets, you know that something's up and that you need to generate that code. Right? All right, I've got all my authors now. I don't want to print them anymore. Right? Iterate through all the books, and how do I iterate through the books? Do this again. There we go. All right. Actually, I probably don't need to do, for each author, actually, let's do it this way, right? Let me do it the stupid way. For each author, dot, 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 for each book, right? Dot, 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 right? If the book's author is equal to the author, right? Then add it to the map, dot, dot, dot. Right? I can do it this way. with 2 for loops. Does that sound efficient though? All right. Think about this. Say that I had 1,000 authors, and suppose that I had 1,000,000 books. Right? 1,000 authors, you're going to go through 1,000,000 books. Right? How many is that? 1,000 times 1,000,000. What do we call them? Trillions. Right? So if I have nested for loops here, really, really fishy. That's a code smell. Right? I'm probably doing this very, very inefficiently. Right? So let's rethink this. All right? What I want to do is I want to iterate through the books once for each book B. Right? All right? Get the set of the or get the set in the map of the books author, of B's author. Or I'll say it like that, B's author. Right? Dot, dot, dot. Right? Add this book, add the book B to the author's set. Dot, dot, dot. Right? That sounds a lot better. Why? How many loops do I have here, at least in my pseudocode? 1. Now, if there are 1,000,000 books, I'm not doing 1,000,000,000,000 operations. I'm doing 1,000,000 operations, and that's it. Right? It's 1,000 times faster now. And trust me, you will want to make your code efficient on the third assignment. In fact, if you can't get it to be efficient and it'll time out after 5 minutes, make sure that you're removing the code that is inefficient, even if you're not going to be able to do all the reports, because at least it'll run, right? And at least we can have something to grade. Okay. All right. So for each book, for book B in the collection books, right? I need to get the set in this map, author map, dot get B dot author, right? Remember how maps work? All you have to do is give it the key. Once you've got the key, it will return the set of that author's books. Author's books is equal to that. There. So I've got the set here, and now all I need to do is add it. Author books dot add B. There. What are you complaining about? Author map. Oh, did I do a list? Oh, you agreed to do a list. Sorry. I was going to do a set. There we go. List. There. Author's books. Author's books. There. Now it compiles. Except, think about this. The first book that we see, let's go up here. Books by rating. The Hate You Give by Angie Thomas. Right? Are we going to have a list of her books yet? If this is the first time we've seen her. This is the first time we've seen this book and the first time that we've seen Angie Thomas. Right? So if this is the first time we've seen this, is there going to be a list of books for her? No. So in that case, what does this return? Right? This is going to be some RTMing, read the manual. Right? And unfortunately, it's kind of small, but if the map permits no, more formally, blah, blah, blah. If it does, there we go. There, it's right at the top there. In fact, I can cut and paste that and put that in Scratch so that we can actually read it. Returns the value to which the specified key is mapped, or null if the map contains no mapping for the key. So if this is the first time that we've seen her and there's no list for her, what is it going to end up returning? Right? If this is the first time we've seen this author, dot, 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 author's books will be null, dot, dot, dot. If it's null, can we add something to it? Can you add something to a null list there? No. So what do we need to do? We need to create that list. If author's books, if that list is null, how do we check for null? We just use equals equals. And remember that null is all lowercase. Not like it's in C, all uppercase N-U-L-L. Not like it's in Python, which is none, right? It is lowercase N-U-L-L. And you'll know that because it's going to be a little magenta there, right? So if that's null, then what we need to do is we need to create it. New array list. There. And now it exists. Either it exists up here or it exists because we've created it on line 111. And we're able to add it down here. Right? And that's what we did right here. There. I'll put that in there. Okay? let's look at it now. System.out.println author's books, author maps, sorry. Right? It's not going to look pretty, but at least we'll see that it works. Right? Oops. Oh, no. Okay, so if we create it, we need to add it. I'm sorry, we didn't do that. Right? There's add the book, and then we need to add it back into the map. Author map dot put, what was it, author? B dot author, and we're going to map it to author's books. There we go. All right, there. So what we've done two things here. We'll add the book to the author's list, right? There we go. And then we need to add that book list, add the book list to the map, right? In other words, we're going to map the author is going to map to the list of books. There. That's as pseudocodey as I can get. Come on. Freezing up. There we go. There. Right? The author will map to a list of books. Now, I've got a whole bunch of stuff. Again, you can come over here and look at it and see where's Terry Pratchett now. Pratchett. There. Pratchett. There we go. There's the first one. There he is. There's Terry Pratchett, and he's mapping to this list. The Witch's Vacuum Cleaner and Other Stories, comma, Monstrous Regiment, comma, Johnny and the Bomb, comma, comma. Let's make this look a little bit nicer. Right? So, for each author in the map, dot, 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 print out the books 1 to a line, dot, dot, dot. Right? This is a little bit more practice on how to use maps and how to iterate over maps. For person, which is an author, in the author map dot key set. So remember, there's this key set that will give you a set of people, right? Oh, I've already used author. Okay, I'll use A there. There we go. I've already used the variable author up here somewhere in a previous demo, right there. So I can't use it down here. Instead, I'm going to have to call it A. System.out.println, A, right? And now let's print out their books. For book B, in the collection, now I need to get that author maps dot get A, right? So I'm getting the list of books based on this key right here, the author key, right? System.out.println B, right? There. Actually, let's tab over so that we can make it look even nicer. Tab, prepend a tab to this thing. There we go. There's H.G. Wells and his 3 books. War of the Worlds, Invisible Man, Island of Dr. Moreau. Where is Terry Pratchett? I can't find him because it's not in any particular order, right? Why? Because like sets, maps are unordered. I'll show you a trick here in a second. But otherwise, where are you, Terry? There you go. There you are, Terry. And there are the 5 books I was talking about. Monstrous Regiment, Johnny and the Bomb, Johnny and the Dead, Only You Can Save Mankind. Right? All right, well, I want to print this out, but I want to be able to find Terry Pratchett a little bit better. I want to make sure that Scott Simon is after Pratchett, that LMNOP, I still have to do that in my head, even though I'm an adult. M comes before P, right? I have to sing the alphabet in my head. Does everybody else do that? Yeah, everybody does that, right? You don't remember your ABCs unless you remember the damn song, right? So I want to print them out, but print out authors in order, dot, dot, dot. Okay? Well, this is a key set. Is a set ordered? Is there a first element, a second element, and a last element? No. So what I need to do is I need to first dump all of the authors to a list to sort it, dot, dot, dot. So a list of persons, which is all authors, is equal to new array list, and I will just simply dump this key set into it. Right? This is called a copy constructor. It takes things in that set and puts them into this list. Right? I'll call it my authors, right? Because I've already used the variable authors up above, right? And now, second, sort it in order of last name, first name. Guess what? Because I went through the process of making this comparable, I don't need to do any more work. All I need to do is say collections.sort my authors. It compiles just fine, even though it's a person. Why? Because I told it how to order using that comparable interface. Right? That's awesome right there. Now what I can do is I can, instead of iterating over the key set, what I can do is iterate over that my authors. There we go. And now let's print this out one more time. Who's the last guy? Zamyatin, right? 1924. And who's the first guy now? Where are we? Douglas Adams. Then Alexander, Anderson, ... Where would Pratchett be now? Right there in the P's. Right? Let's see. How do we look for ties? I don't think I have any ties in here. Dune is by Frank Herbert. So do I have Herbert in here? Okay. I've got Brian Herbert, his son, but I don't have Frank Herbert, the father. But you can see that Brian would come before Frank Herbert. What's the problem with Homer, the Odyssey by Homer? There is no last name to Homer. So how do you deal with that? I don't know, right? How do you deal with the fact that it's 700 BCE, right? It's negative 700. Again, if you use a proper class like a local date, this would have come out as 700 BCE instead of negative 700. Yeah. It looks like we. Oh, why is that? Yeah, exactly. It's the data. Let's see, Miller. Fine, Miller. So when I changed the data, I didn't figure that there would be titles in there. So let's go ahead and get rid of that. Walter M. Miller. So Walter. There. Miller is probably a last name though, right? I don't know. There. Now the data is fixed. I'm pretty sure it's Walter Miller. Can't Go for Leibowitz. Anybody read it? No? Okay. It's a really great book. Recommend. Don't recommend all of these, but most of them I would recommend. All right. So remember, assignment 1 is due this Friday. You can do things in many, many different ways, but always look for smart data structures and smart algorithms, searching and sorting.